So for section 10.5, we're going to be looking at graphing three specific polynomial functions, the absolute value function, some piecewise functions, and some greater integer functions. I first want to start by looking at an absolute value function. So when you're graphing an absolute value function in two dimensions, the first thing you're going to want to start with is what I'm going to call the vertex. Now, vertex is not the technical term for it, but it is the highest or lowest point on the graph, and it's the turning point on the graph. Now, this is written in vertex form, much like quadratics are, so you're going to pull it out exactly the same way. The x-coordinate is going to become a -1 when you rip it out of the absolute value, you change the sign. And your y-coordinate is going to be a +2. We're not changing the sign because we didn't rip it out of anything. So if I go to -1, +2, there's my vertex right there on the graph. Now absolute value functions are graphed as v's. So there's an increasing section of the graph to the right and an increasing portion of the, or an decreasing, excuse me, portion of the graph to the left. So it looks like a V. So what we have to do from this vertex that we just found right here is identify our slope or our rate of change, and that will tell us how far up and left to go on both sides. So, or down, if it's a negative, or down, it'll be a downwards V. And the way that we find that is actually it's this number on the outside. So in this case, our slope, and once again, slope is not necessarily the technical term there. The slope would be -1/1 because that's what that is. And so we would go down 1 over 1, down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. That would create half of our V on this side. Now we'd go down 1 and to the left 1 to create the other side of our V. So basically, you actually go both directions. You would go down and right and down and left, which is why slope is not technically the technical term. I mean, what this does is it creates your absolute value function. For our second graph, I want to go ahead and look at a piecewise function. And basically, a piecewise function is two separate graphs put on the same graph paper. So, for example, we have the function 2x, and we also have the function x minus 1. Now, the first thing that you want to do is you actually want to find the starting point of each of these graphs. And the way that you do it is you take this -1, this end point, and you plug it in to both of them. And you plug it in as an x. So if x is -1, what's y? If x is -1, what's y? And you literally plug it right in. So if x is -1, this is 2 times -1, -2. If x is 1, it's -1 minus 1, -2. Now in this case, they're both the same. I'm going to show you one in a second where they're not the same, but in this case they are the same. So I'm going to go over to my graph, and -1, -2 is going to be my end point or starting point for both of these graphs. Now from here, we just use a t-chart. But the trick is using the correct numbers. If you look up here in our graph, it's 2x only if x is less than or equal to -1. So if it's less than or equal to -1, my x's need to be smaller than -1, such as a -2 or a -3. For x plus or x minus 1, it's only that if x is greater than -1. So greater than -1 might be 0 or a +1. So now I take those x's and plug them into these functions to get the rest of my points. So if I plug in a -2, 2 times -2 is -4, 2 times -3 is -6. So I got -2, -4, and I've got -3, -6, making this one of my lines. Now I need to get the other half. Remember, don't go past that endpoint, because past that endpoint is my next graph. My next graph is this one right here. I'm going to plug a 0 in. 0 minus 1 is -1. 1 minus 1 is 0. So 0, -1, 1, 0. Making my second graph almost a little bit flatter going this way. This is a piecewise function. So in essence, what you have is you have two complete separate graphs. You have this graph, which represents x minus 1. And then you have this graph down here, which represents 2x. So you've actually got two separate graphs in a piecewise function. So let's go ahead and look at a different piecewise function. So this is the second piecewise function I want to look at. So basically we've got two separate functions. We've got 4 minus x, and we've got 1 plus 2x. And if you remember correctly from the last problem, the first thing I said is plug in that endpoint. In this case, the endpoint is a 2. And remember, we get that from right up here. So what we want to do is take that 2 and plug it into both of them and see what we get. So if I plug in here, we get 4 minus 2, which is 2. If I plug it in here, we get 1 plus 2 times 2, which is 5. we have two separate endpoints here. We've got an endpoint at 2, 2 and an endpoint at 2, 5. Now, one of these is going to be a solid circle, and one of these is going to be an open circle. And the way that you determine that is by whether this is underlined or not. So the 4 minus x is not underlined. Since the 4 minus x, that inequality, is not underlined, that's actually going to be our open circle. And if you check over here, since the 1 plus 2x is underlined, that inequality symbol is underlined, that's going to be our solid circle. So as we go into the problem, for 2, 2, we know it's going to be an open circle, and you literally just draw an open circle. And then for the 1 plus 2x, you're going to go to 2, 5 and draw a closed circle. And the reason we can't have both of those be closed dots is because you can't have multiple outputs for one input in a function. That's one of the rules of a function. Now from here on out, you're actually going to just use your t-chart, like you did on the last one. So be careful, you got to check your rates. This, for the 4 minus x, it has to be less than 2. So less than 2 might be a 1 or a 0. And up here for 1 plus 2x, it's got to be greater than or equal to 2. So you might be looking at a 3 and a 4. So we plug those in. 4 minus 1 is 3, 4 minus 0 is 4. So my first graph with the endpoint of the open circle is 1, 3 and 0, 4, going up that way. Now to get my second graph, I'm going to plug in my 3 and 4. So 1 plus 2 times 3 is 7. 1 plus 2 times 4 is 9. So 3, 7, 4, 9. Looks like it's going to go up this way. And that would be my piecewise function. So once again, we're representing two different functions. Here's your 4 minus x represented right here with the endpoint of an open circle, and here's my 1 plus 2x going to the right here represented by a closed circle. All right, now let's look at a step function. This is called a greatest integer function, or a step function. You've never seen this before. It's brand new to college algebra. So basically a step function is an integer function. So what it means is if you would plug in, for example, a 1, it would be any integer closest to 1 as long as it doesn't reach the next. So that sounds so silly, but if you graph it, it actually makes a little bit more sense. An integer function or a step function, it's going to be hard because this graph is small. It's a closed, and then you draw a line, and then it's an open circle. And then you go above it. Closed, draw a line, open. Closed, draw a line, open. Closed, draw a line, open. You literally are supposed to go all the way through the graph. For the sake of time, I'm not going to go all the way through the graph. I'm just going to show it like that. So it's the greatest integer function. So if you plug in a 1, the greatest numbers that are closest to it, to the next integer, would be 1, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, but it can't be 2 because automatically you jump to the next greatest integer, if that makes any sense, which is why you have all those, open circles and closed circles as you go. So that's what the greatest integer function looks like, and it is okay for you to do just a few of them and then go ahead and draw your arrows because it can get long and tedious. So let's look at a greatest integer function with a shift. So when you have stuff added or subtracted to a greatest integer function, you shift it exactly like you would shift something in vertex form, or exactly like we shifted the vertex in the absolute value functions. So in this case, since there's nothing added or subtracted to that x, there's going to be no left or right shift because there's nothing in there. But there is going to be an up-down shift due to that too. So this number represents an up-down shift, and this represents we're going to go up 2. So we're going to start our step function at 0, 0, but due to that shift, we're going to shift up 2. And then from there, just create your integer function. Just instead of from 0, 0, you create it from 0, 2. So it would look like that. And once again, you could draw your lines through that to indicate a continuation.